Hello, my name is Sanjay, and today talk about evaluation of the GSC ceramic edition on the mechanical and tribological properties of the aluminum 10 copper alloy processed by electrical arc melting. 2000 series aluminum alloys are widely used in engineering component manufacturing because of the low density, good mechanical properties, and affordability. A new reforming strategy for the two series involves adding more than 5% by weight of copper, with many low wear resistance and limits its performance and use in the automotive industry. The addition of the YSZCERAMIC refractory material helps create a thermal barrier against heat generated by friction. In this context, research developed composition material we using an all aluminum 10 copper alloy as matrix and 5, 10, and 50 and 28% of GS particle reinforcement and fabricate a composite with a total weight of 2.5 grams. When I obtain all the composition, the file composition, this pass for a compaction. In the compaction, press with a charge of with a load of 500 megapascals and obtain the compacted. The compacted pass to electric arc-melting in an inert argon atmospheric and finish the process to the electric arc, pass to the metallographic preparation. In the metallographic preparation, do with grease sanders and alumina. Finish with that, I section the sample section in two parts, all the sample, and one part I do a chemical attack with a cross to revalidate the microstructure and continue with do analyze like SDR and SEM. And the other part of the samples do a bigger microhardens with a 500 grains force and do a reciprocal wear with a constant load in 0.2 newtons. Okay, this process this analysis result in these results. Start with the S-ray diffraction and same in the figure one you can see the diffractogram and you can notice all the phase percent in the material and you can notice the diffractogram for the down for the first composition the 0% of GSC and compare it with the figure 2 the EDS composition mapping of the 0 GSC you notice the first percent is aluminum purum and the intermetallic copper aluminum 2. This intermetallic is present in this microstructure. This microstructure is a dendrite. It is configured with a composition mapping of the copper present inside C, and you see the copper unity or principlement in these dendrites. Would you continue with the other composition? With the five composition, you notice a other phase percent. The other phase is obsidian zirconium and aluminum zirconium. Is like this and percent in percent because I added the reforce. And if you look at the figure 3, you see in the 6A the I located the GSC in this type of dendrites. This is a laminar dendrites, but in the form of irregular, and this is configured with the insides E and F. In you can see the percent of the yttrium and zirconium in only this space. When I continue with the 10% of GSC, the other continue on Unity operates more percentage of these phases of these intermetallics and the oxidants And in the figure 4, you can see the micrographies and the mapping composition elements for this composition. And you notice the laminar dendrites have a more large and more definite structure. Continue with the 15 and 20%. In the 50%, the other four separate lumina. The alumina is a more common oxygen percent in aluminum alloys, and the other intermetallic percent in only in the 20% of GSC is a aluminum zircon. Is like this, and when you see the figure number 5, you can see the micrography. The laminar dendrites are more big, take more area in the composition, and this is corroborated with in this A and F, and you can see the all the GSC unicorn percent in these areas. Continue with the mechanical properties. You can look in the figure 6 the hardness, the micro hardness, and you notice when you add more GSC, the micro hardness increment. Finally, the 20% of GSC have a 138 beakers. This is a 84% increment that the 0% of GSC. This increment is related with a what fastest percent in the material, because for a more GSC, more fast percent, more intermetallic operate or generate in the sample. Continue with the figure 7. You can see the coefficient of friction, the cuff, and you notice the 0, 5, 15, and 20 start with a curve between the zero point 0.6 to 0.4, and there's the crease are in an increment in another when I pass the time, and finally stay near in between into point 0.75 for point 58, 59. This is the tendon. This is the zona where put of the cup. Unicorn difference is 10%, but this is because when I did the proof, the material present adhesion in the supervise when I do the wear testing. Continue with the figure 8. You can notice attendance. The specific wear rate reduced when you add more GSC. The material with the sample with a 15% have at the minus a specific wear rate. What is the reason? The reason the reason is because in this composition didn't have the other intermetallic. The other intermetallic, I say the aluminum zirconium. This is the principal difference between 20% and 15%. The other quality, the other composition, the other elements is similar. The other phase is similar, but this is the principal difference. And what is the percent of decrease? Percent between the 0 for to 15 is 91%. This is a very big decrease and very good because it's a reduce the effect in the superfice or the material. And continue with the figure 9, you can see the wear track profiles. And you notice when you have a more GSC, more percentage of GSC, the dip reduce and the distance reduce, but except for the 10 GSC. And repeat what I say in the figure 7. This is because when I did this proof, the material present adhesion, not this gas, not a weir, not weir. Continue with the figure number. Sorry for that. Continue with the figure 10. you can notice a 3D topographic appearance. In this appearance, you can notice with a table with a skull in the left, the color for the material. You notice with you see it's more simple to notice the we are right there, the uh, we are track of the profiles, and you notice in CC you can notice the adhesion in the middle or around the where I do the test, and on all of the superface around this hole the track profile the track the rear track present more material. I suppose is because uh, the material is contaminated with a trash or the take pulp. But this is actually my project, and I suppose yeah, I decide the better option for use in the industry automotive is 15% of GSC because very good micro hardness present a very good resistance to the reciprocal resistance because have the minus specific word racing have the minus deep in the weird track profile it's accepted 10%. And this is all for me. Thank you very much.